All right, welcome. Today, we're going to pull back the curtain on the internet and look at the secret map that guides literally everything we do online. It's called the OSI model. So let's follow the data and see where it goes.
You know how it is. You find an article you want to read, you click the link, and poof, there it is. But in that split second between your click and the page loading, your data goes on this absolutely incredible lightning-fast journey. We're going to follow that journey every single step of the way.
So, to follow this trip, we need a map. And for the internet, that map is the OSI model. And look, forget what you might have heard about boring technical standards. Think of this as the secret blueprint, the universal guide that lets any two computers on planet Earth actually talk to each other. Okay, a quick reality check. The internet you're using right now, it actually runs on a simpler, more practical model called TCP/IP. So you might be asking, why are we learning this one? It's because the 7-layer OSI model is the ultimate master blueprint. If you get this, you get the theory behind any computer network. It's the key. And here it is. This is our map, the 7 layers of the OSI model. Now, when you send data, it travels down this stack from layer 7, application, all the way to layer 1, physical. You can think of it like an assembly line, where each layer adds its own special part to get your data ready for the trip.
Feeling a little overwhelmed by 7 layers? Don't be. Here's a fantastic little trick to remember them in order, from top to bottom. Application, presentation, session, transport, network, data link, and physical. Just remember, anxious pale Shakespeare treated nervous drunks patiently. Yeah, it's a little silly, but trust me, it works.
Okay, let's start our journey at the very top, where your data is basically born. These first 3 layers are all about software, and they have one job: preparing your information for its big adventure across the network. So we're at the starting line, layer 7. When you type in a web address and hit enter in your browser, that's your software talking to this layer. It's making a request, probably using something like HTTP, to get this whole process started. This is the official handoff from your app to the network.
Next up, your data meets the universal translator, the presentation layer. This is where your request gets converted into a standard format so that any computer, anywhere in the world, can understand what you're asking. It also plays security guard, handling encryption, and it's an efficiency expert, compressing the data so it takes up less space. Pretty cool, huh?
So think about this. You've got multiple tabs open in your browser, right? Maybe a video streaming, your email, and a news site. How does the data for each one stay separate? Well, that is the magic of the session layer. It opens, maintains, and closes a totally unique connection for each specific task. It's like a switchboard operator, making sure the data from your video doesn't get mixed up with your email.
Okay, our data is prepped and ready to go. Now it hits layer 4, the transport layer, and it has to make a huge decision. Do we need this to be fast, or do we need it to be perfect?
And that choice comes down to 2 protocols. On one hand, you have TCP. Think of TCP as certified mail. It establishes a solid connection and guarantees every single piece of data arrives, and in the right order. It's perfect for a web page where every word has to be there. On the other hand, you've got UDP. UDP is more like sending a postcard. It's fast, simple, and best effort. If a few pixels drop on your video call, who cares? The important thing is keeping that stream moving without lag.
Oh, and no matter which protocol gets chosen, the transport layer also acts like a chef. It takes your big chunk of data and chops it up into smaller, much more manageable pieces. If we're using TCP, we call them segments. If it's UDP, they're called datagrams. It just makes everything easier to send.
So, our data is chopped up and ready to ship. But where exactly is it going? It needs an address. Actually, it needs 2 very different kinds of addresses to get to its final destination.
First up is the network layer. This is where your data gets its IP address. Think of this as the full mailing address, the city, state, and street name. It's a logical address that lets routers all over the internet figure out the absolute best path to get your data to the right network.
So, once your data gets to the right street, the data link layer takes over. It adds what's called the MAC address, and you can think of that as the specific house number. This is a physical address that's literally burned into your computer's network card. It makes sure the data gets delivered to the one exact correct device.
So just to make it super clear, the IP address gets the package to the right street, the MAC address gets it to the right front door. You absolutely need both of them to make a successful delivery. No way around it.
And we've done it. Our data has been translated, packaged up, chopped into pieces, and given 2 addresses.
It's traveled all the way down the stack, and now it's time for the most dramatic part of the entire journey. This is it, the moment of truth. Everything we've done so far has been digital, happening inside the computer's brain. Layer 1 is where our data finally makes the leap into the physical world. At the physical layer, all those carefully prepared ones and zeros are converted into actual physical signals. We're talking millions of electrical pulses shooting down a copper cable, or flashes of light pulsing through a fiber optic line. The digital literally becomes physical. It's kind of amazing when you think about it. And just like that, our data is on its way. That whole trip from layer 7 all the way down to layer 1 happens in the blink of an eye. So what's the big takeaway here?
Well, of course, communication is a two-way street, right? When those signals get to the destination computer, this entire process just happens in reverse. The physical layer turns the signals back into binary code, and the data travels all the way back up the stack, from 1 to 7, where it's handed off, perfectly reassembled, to the application on the other end.
And that's really the power of this model. Even though it's theoretical, it shows you the incredible synchronized dance between software and hardware that happens flawlessly every single time you click a mouse. It's the hidden logic that makes our connected world even possible.
You know, this entire framework was designed way back in the 1970s, almost 50 years ago. And it makes you wonder, as our technology evolves into things we can't even begin to imagine yet, what new invisible maps will be guiding our data's journey tomorrow?